Is it really easy to use the STL heap?
Yes. So the STL has a heap.
Yeah. All hell.
This is surprising not that bad, although it is a little weird at first. A heap is a vector that's been heapified. All right. Again, a heap is a vector. So when you're going to use a heap, you create a vector. Let's go create a vector.
Okay.
So you have.
Very nice, very nice.
So you have to use it.
You have to use a what? I'm sorry?
You have to use it.
Yes, because a heap is just an array, right? Right. A heap is just an array, just organized a certain way. And so therefore you just use a vector.
The vector is in every single way better than just an array.
No. An array has better performance characteristics and consumes less memory, but a vector has better facilities for coding.
Still sounds better.
What's that?
Still sounds a lot better.
Most of the time it
I'll
is.
take that small better.
Most of the time it is, unless you're writing a Linux kernel and you don't have the STL and you have to rewrite the whole thing yourself.
And then it starts to be good.
Well, no, you just don't use the STL because it's bloated. Yeah, it's way too big. All right, which one am I taking from? Binary tree? Yeah. All right, so let's go and make a. Well, let's just edit main. That'll make it easier. All right, source, main. Forget all this. All right, so we're going to include vector. So first thing we need to do is create a vector. All right. Heap. Great. Perfect. All right. Use the make heap function to heapify a vector. So let's go ahead and heap.push back. All right, give me some numbers.
Negative 1111.
27.
Oh, wait, did you prepare for the negative numbers?
46.
Putting it all.
24.
No.
Here's no. Take that.
9,001.
Yeah, I was waiting for that one.
Oh.
It's over 9,000.
It's over 9,000. Okay. All right. So let's go ahead and make a little print function real quick.
Okay.
Void print. Which will print a vector for us. So let's go ahead and let's do it the easy way. Int I equals 0, I is less than vec.size, I plus plus. C out. What was it? Vec sub I. And we'll just put a space. All right, let's see if this works. Well, it compiled. No. Didn't do anything. Oh, I know why.
I think you're throwing an exclamation point before make.
Well, I also don't actually call print.
Oh, yeah.
I mean,
That could make it.
details.
You don't know. I mean, that may be the
There we
issue,
go.
you know?
All right, good. It printed it out. Excellent. And then what do we do next? Make heap? Make heap. Let's see where that is. I'm using the good old C++. Oh yes, this website. Hopefully you've all seen it before.
That is my friend.
It always takes a while to load. I've never understood that. All right, it's part of algorithm.
Oh, that one.
Yeah.
Use it on a project, so you couldn't. I got stuff.
Alright, so then we'll go ahead and do make heap on the heap. And then we'll print the heap again. Let's see. Oh, we gotta do std in front of that. Oop, didn't like that. Oh, we gotta pass it the first and last. Alright. Heap.begin. Heap.end. Alright, let's go ahead and make a new tab so this is a little easier to see what's going on. Okay, great. Oh, so it's doing it by largest.
But 24 is
That's fine. I'll go ahead and draw this out on the board. So what do you have? 9001, 900, 1, 2, 3, 54, 24, 27, 6, 46, 1, 22, and negative 1, 1, 1. All right, is that a heap? Looks like a heap to me. Every element is larger than all of its children. Or just really just its children. All right, looks good. So, looks like make heap can do that. All right. Bet you wish you had that for a previous lab. Further pushes and pops need to be done via heap functions. So you have pushback plus push heap. Some example code will help. So let's see, push back and then push the heap. All right. So let's say you want to. Whoops. To add an element, you would do, let's see, heap dot push back. What number do you want to add?
350.
350. 50.
350.
350.
All I got is 350.
And then you have to do a push heap. Yeah, and then you do a push heap, heap dot begin, heap dot end. And then we'll print it again. There it is. Now that's the one weird thing here is that you have to push the number and then immediately call push heap, because first one obviously just adds it to the vector and the second one does the whole sift up.
So basically does less than make.
Well, make heap if you have a. Oh, I'm sorry. Ask the question again.
Oh yeah, like what's the difference between make heap and push heap?
So make heap, you have a vector and you need to heapify the entire thing. Well, push back and push heap only is going to percolate the final element.
So does that mean that you can just add a bunch, like how we did at the beginning, push back to the vector?
And then
just
call
have-
push heap every time? Yeah, you
Yeah.
can do that.
Well, like, I mean, you have a long series of pushes and then you just have the one push heap.
No. You have to call push heap after every pushback. Because push heap is only going to percolate up the final element. It's not going to go through your whole heap and make sure it's correct. It's only going to find that last element and make sure it percolates up to the correct location.
So basically it's one time
Okay.
make heap.
Yeah.
You whole
Yeah.
block
So it's here,
you got.
don't put the last number.
You got it.
You could just do push heap the whole time instead of.
Right. I could, right after all these pushbacks, put push heap.
Okay, and
Yeah.
that would replace. doing
Yeah, and then I wouldn't have to do make heap.
Okay.
Well, just for fun, let's add another number. What number do y'all want? 9,002. Boom. There it is. Excellent. All right. And then it's probably just pop heap, if I recall correctly. Pop heap. So, to get the top, you would do, let's see, is I'm sorry, heap dot front, and then to pop. You do, is it just pop heap? Pop heap, great. Actually, do we have to begin and end or just begin? Nope, no, we have to do the whole thing. Cool. And then we'll print the heap again.
Basically, this is iterating through the whole thing every single time.
What's iterating through the whole thing?
The iterators, because we're sending in the first iterator and the second iterator.
Oh, that just tells it where the beginning and the end are,
Okay.
so it knows where to go.
So
But it's not
goes
iterating
last.
through the whole thing. No.
Okay. So it just goes to the one right before end. And
Mhm.
then goes back.
Mhm. It just takes in and goes back one, and then knows to shift that one up, and knows to stop once it gets to begin or before begin. And got rid of 902. Oh, look at that. Now, did that, that was fun. So notice, and that's one thing to keep in mind, is that I did not adjust the size, which actually is not surprising. Because if you remember how heaps work, that's what they did. They shifted it with the last one. So keep that in mind when you're using the STL heap to implement your lab. All right, just some other things. Make heap, heapifies a vector, push back plus push heap, pushes the heap, pushes to the heap. That's really the only tricky part is you have to call both. Pop heap removes the first element and reheaps, although keep in mind that your size is not necessarily adjusted. Front gets the top element, first in the heap. Sort heap performs heap sort. Notice that the vector is no longer a heap afterwards because now it's sorted. Is heap is a quick test to see if you're still a heap. That's great. Is heap until returns an iterator. What part of the heap is a heap? Oh.
Certain situation.
Yep. Oh, comments. Do y'all have any comments?
So you're actually
2 plus 2,
letting us
that's
use
4.
the STL.
Plus 1, that's 3 with math.
I'm sorry, say that again?
2 plus 2 is 4.
Yes.
3 common.
Well, at least for base 5 systems and greater.
Not unless you overload the plus. You overload that plus number, 2 plus 2.
Yeah, I could also overload plus and make it happen, do whatever I wanted to. Because C++ is like that.
So do these heap algorithms work for linked lists as well? Or like data lists?
I'm pretty sure you have to use a vector.
But if you have to use a vector, then why?
Yes, you have to use a vector. Okay, actually, I take that back. You have to use something that implements the random access iterator.
So because if you just had to use a vector, why would they just like add it as functions to the vector itself?
Yeah, that's a good question. The answer is from an OOP standpoint. What if, for some weird reason, you wanted to use something besides a vector? So they wanted to make sure they had a level of indirection that allows you to plug it in. And the way they did that is, as long as it implements a random access iterator, which is pretty much just vector, but you have something else that implements random access vectors, then make heap will work for that as well.
Interesting.
All right, well, priority queues data structure is designed to return elements in order of priority. Efficiency is used to measure the sum of the time it takes to add and remove. Great. Simple implementations O of n. A heap takes log of n. Therefore, for any sort of heavy-duty use, a heap implementation is better. Really, just use heap, period, because it's not that bad. Oh, my recommendation? This is the author's recommendation. Okay, yeah, ignore that. The end. Any questions? Yes.
So after doing remove on the heap, since it didn't adjust the size, would you then do pop back with the vector and shrink to fit?
Yeah, if you want to, yeah. Pop back. Well, you can just do pop back.
Oh, it does it automatically.
And then it will shrink it. Yeah, it would. All right. And why don't we just show that? So notice that pop heap, you really should actually call pop back and then print the heap afterwards. Oh, it's not. Is it pop?
It's the fallback.
Oh yeah. Craziness. I must be tired. There it goes. And then they got rid of it.
Okay.
So just keep that in mind when you implement remove in your lab.